Welcome to a video on redox titrations. This can also be commonly referred to as transition metal titration. Now in chemistry, we've already done acid and base titrations where we mix an acid in a burette with a base or an alkali in a conical flask. It could also be done the other way around. However, in redox titrations, we're not going to be reacting an acid with a base. Instead, we're going to be reacting an oxidizing agent with a reducing agent. So just like we had to know some acids and bases, let's get to meet some oxidizing and reducing agents. Manganate, MnO4-, is the most common one that we'll be using in A-level chemistry. Manganate, because it's an oxidizing agent, will get reduced from MnO4- to Mn2+. Now this will be done in acidic conditions, which means to complete this half equation we can use hydrogen ions, water and electrons. This is what the completed half equation looks like. Okay, now one more thing about this. Manganate is purple and manganese Mn2+ is colourless. This is useful to know because unlike acid and base titrations, transition metal titrations do not use indicators. Because the transition metal itself changes colour, we say that it is self-indicating and therefore we do not need an indicator. Okay, so now, as for reducing agents, we have iron 2+, which turns into iron +3, and electrons. And we also have this molecule, ethane dioate, which reduces into 2 carbon dioxide molecules and 2 electrons. So, as you can see, reducing agents lose electrons, which are then gained by the oxidizing agent. So, redox titrations are literally just to do with the transfer of electrons. Okay, so now what we're going to do is we're going to take some half equations and combine them to find an overall equation. This can help us in calculations. Once we know the mole of one thing, for example manganate, we can then work out the mole of the reducing agent like iron. So now that we've seen the half equations, what we're going to do is combine them such that we get an overall equation, and this will then help us when it comes to molar calculations. So let's say that in our redox titration we are reacting manganate, the oxidizing agent, with iron, the reducing agent. So first of all, we're going to complete their half equations. So we have the manganate half equation and we have the iron half equation. Okay, now remember, in order for us to be able to add these equations, we have to make sure that the electrons on both sides are balanced. As you can see, the number of electrons in the half equations are not balanced. Manganate has 5, whereas iron has 1. So now we have to multiply the bottom one, iron's half equation, by 5. Once we've done that, we should see that the entire half equation has been multiplied by 5, and now the number of electrons on both the half equations are the same. Now we can add them together. After adding them, you will notice that the electrons will cancel out, giving you this final overall equation at the bottom. From here, we can see that iron and manganate have a 1:5 ratio. Okay, let's try a different reducing agent. So this time, we're going to react manganate with ethane dioate. So just like before, we're going to write the complete half equations. Notice that manganate has 5 electrons, whereas ethane dioate has 2 electrons. So now that we have the number of electrons, what we can do is see what they both go into. So now we can see that 5 and 2 both go into 10. So we're going to multiply the top equation by 2 and the bottom one by 5. Once I've done this, I should now get the new half equations. Okay, so now after multiplying, this is what we get. Okay, there we go. So both equations have been multiplied. Okay, number of electrons on both equations are the same, which means we can now add the two equations to cancel out the electrons and give us the final overall equation. And we can see that the ratio of manganate to ethane dioate is 2:5. Okay, some final points about redox titrations. So, in a redox titration, a reducing agent is mixed with an oxidizing agent. In the case of manganate, it will react with either iron or ethane dioate, or sometimes both can be mixed together. These guys will provide the electrons. At the same time, we also require hydrogen ions for the complete equation. As you can see here, manganate reacts with electrons and hydrogen ions. Now, the electrons we can get from the reducing agent. But what about the hydrogen ions? Most commonly, dilute sulfuric acid is added to the conical flask to provide the hydrogen ions required for the reaction. Hydrochloric acid is not used, and the reason behind that is because it releases chloride ions, which themselves can act as a reducing agent. So, for example, if you're doing a titration and you only expect to use 20 centimeters cubed of manganate, and all of a sudden you've used 40, you're thinking to yourself, oh, I must have a lot of reducing agent. No, you've actually just thrown in loads of chloride ions, which are also reacting with the manganate. Also, weak acids like carboxylic acids are not used, and the reason behind that is because they do not provide enough hydrogen ions. So, that was our introduction to redox titrations. In the next video, we're going to try some calculation examples. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.